All right, it's 1:04, so let's go ahead and get started. So welcome everybody. Good afternoon. This is the June 30th, 2026 SunSpec Alliance Mid-Year Standards Development Update webinar. My name is Dylan Tanzi. I'm the Executive Director of the SunSpec Alliance, and I'll be joined by a few others to go over a few of the topics that we're going to be discussing today. Including Steve Kang of Quality Logic and Dave Cole of Cole Consulting, and also Aaron Mahan, VP of Membership and Regulatory Affairs for the SunSpec Alliance. So for those of you who are not super familiar with SunSpec, we are a nonprofit trade alliance in the distributed energy resource industry. Our reason for being is to grow the distributed energy resource industry. And the way we do that is by developing, deploying, and supporting open, royalty-free communication and interoperability standards. We've existed since 2009 and have had great success. Originally founded as a de facto standards-making organization where our members supported these standards on a voluntary basis. And we saw great uptake over the years and have now at this point been written into multiple national and international grid codes, including the North America, which has been, for the last couple of years, we've been really focusing on supporting manufacturers developing their communication interfaces for complying with the North American interconnection requirements with IEEE 1547. In recent years, though, the standards development efforts have really been picking back up, and we've been making a ton of new progress and important progress addressing different national, international grid codes and requirements, improving the standards themselves and the associated test procedures. The way that we support ourselves while publishing all of our specifications and standards on an open royalty-free basis is through membership and product certification. So all of our standards come with a conformance profile and open test procedures as well. And we work with a network of authorized test labs, commercial tool test software providers, and manufacturers to enable compliant interoperable devices to come onto the market. And so to go over some of the basics before we dive into the topics, so the antitrust and intellectual property provisions. All SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and IP provisions defined in the SunSpec member agreement. You can see the URL for the SunSpec member agreement there on the screen as well. These are the same rules and provisions that govern the SunSpec work groups where we define all of these standards on a collaborative and consensus basis. So everything that we're going to be going over today is developed in these SunSpec work groups by our members on this consensus basis, governed by these policies, so we can publish all resulting specs on an open, royalty-free basis. So one of the calls to action today is to encourage you all, if you're not already a member, to join the Alliance and also come and participate in these ongoing standards development efforts. So we strictly prohibit SunSpec members and participants from using these meetings as a forum for communications that violate antitrust laws, of course. Confidential or proprietary information should not be discussed in open session, and you can contact SunSpec management if you have any questions about this. A couple quick notes. This meeting is being recorded, so please do keep your camera off and yourself on mute to keep background noise to a minimum. At the same time, like Sam mentioned earlier, I do welcome you to use the raise your hand feature in Google Meet, and I'll interrupt to take your questions live if you so wish. Time permitting, we'll also have a Q&A at the end. And you can, if you prefer, you can ask your questions in the chat as well, and we'll see if we can get to as many of those as we possibly can at the end. And of course, as people always ask, the deck and recording will be distributed after this webinar the next day or so. So for today's agenda, we're going to be looking at the the work products and ongoing work out of the two main SunSpec work groups, the SunSpec Modbus work group and the SunSpec IEEE 2030.5 work groups, which is currently running on two tracks right now with a VDG track and generic 2030.5 and CSIP test procedures update. Due to 2030.5 itself being updated, CSIP being the rule, the required communication interface for California under California Rule 21. Those are being revised to comply with the most recent IEEE 2030.5 standard. So these are some important work activities that have driven a lot of business for SunSpec and have driven hundreds of certifications for all of the manufacturers doing business in California. We're also going to discuss SunSpec Europe, which is a new initiative. We'll get into more details here shortly near the end of this webinar, where we are opening up the SunSpec Europe operations to have local representation to help those in the local market adapt the existing global SunSpec standards and communication protocols for the local requirements and environment, regulatory schemas, and so on. We'll hear from Aaron on that topic here at the end as well, dive into the details there. So with that, let's get into it. I wanted to start today's webinar and discussion by highlighting Secure SunSpec Modbus. This was a new specification. This is a completed work. It was voted by membership in the work group to be approved on December 10th, 2025. And this was a very important development, not only for SunSpec, but for the industry as well. As national requirements are enhanced and cybersecurity becomes mandatory, we know that all communication and information traffic over the public networks and the internet is going to need to be secured and encrypted, including Modbus traffic. Although by convention, Modbus has primarily been the local network area communication protocol, is not always on the public, on any sort of public networks. In the cases where it is on public networks, it is going to need to be encrypted and secured. And we're already seeing regulations all over the world to mandate that. So this was a very important activity. Like I said, the implementation guide was approved on December 10th, 2025. It's based on the modbus.org, Modbus TCP security specification that has existed for many years. And so we based the Secure SunSpec Modbus implementation guide on that previously existing standard, and also adapted some of the rules and regulations from outside regulations like the Cyber Resilience Act and the Cybersecurity Act in the EU to include things like the role-based access control to align with what is in IEC 62351-8. And so it includes mutual TLS for encryption, and it preserves everybody's existing SunSpec Modbus implementations. So you can, manufacturers and device people with SunSpec Modbus communication interfaces can continue to use their existing communication interfaces and use this to secure the traffic if it's done over a public network. And like I said, all of our specifications come paired with a testing criteria in order to validate that any adopter or implementer has done so in a compliant manner. So that to that end, since we completed the implementation guide, the SunSpec Modbus work group has been working on the Secure SunSpec Modbus test procedures. And this specification was voted into test status at the last SunSpec Modbus work group meeting on May 13th, and we're announcing that today. And so this specification in test status has already been published on the SunSpec website in the specifications for review section, and on the public specifications for review section, and in the SunSpec member portal. So you can access this on the website now. And we've extended the public comment and review period to August 1st. So there's still time to download the spec, review it, and enter your comments or any issues that you have. And I really want to strongly encourage and invite people to actually begin implementing Secure SunSpec Modbus and stress testing using the test procedures in your own environments to help us uncover any issues or gaps that we might not have anticipated. There's already tools available to support Secure SunSpec Modbus, including one of the member benefits, SunSpec Dashboard, piece of software included with SunSpec membership. It does already support Secure SunSpec Modbus, so you can encrypt it and test out your own devices. It includes device simulators and and also a SunSpec Modbus client that has secure SunSpec Modbus enabled. Additional resources that you'll need to implement and test during this review period is that in the SunSpec GitHub repository, we do have the script available for you to generate your own insecure test PKI certificates. So everything you need to begin implementing and evaluating and stress testing this test procedure, this specification, is available right now. So I really want to strongly encourage everybody here who this might apply to get the spec and do this testing and provide us on the SunSpec website with your comments, your feedback, your edits, etc. All right, so moving on, the next topic, what we've started working on as the secure SunSpec Modbus test procedures have been in this test phase of public comment and review. We started working on developing a new standard SunSpec Modbus model for grid forming applications. And we got an input from one of our members who did their own custom vendor-specific model as a starting point, and we've already begun adding to it and identifying key features and functions to it that we believe will be required. However, we do need we do need and want additional expertise in this area. And to that end, I'm going to invite Dave Cole to go ahead if you want, turn on your camera and talk us through a little bit more about some of the known knowns and known unknowns, things that we need to shore up our gaps in understanding in order to make sure that this model is what it needs to be useful in the industry. Dave?
Sure. Thanks, Dylan. I don't know if I'll turn on the camera. I've got limited bandwidth on here, so I will just leave it and talk. So I put together a brief one. I think everyone on here understands the differences in grid following and grid forming, but to just put a little history on it, to date, everything we have with the SunSpec series, the SunSpec Modbus 700 series models defines requirements for utility action for grid following DERs. Examples of the grid following would be solar, battery, wind inverters, electric vehicle chargers, battery energy storage systems, various other systems like that. These systems are designed to be a current source, which monitors our grids looking for specific conditions in the phase, voltage, frequency. Then they synchronize the said conditions and only allowed to enter service and begin to export real reactive power on the grid. As the injection of the synchronized power provides grid support functions as defined in the SunSpec Model 701 to 715, it helps provide secure and stable grids across the world. That's amazing. It's a great technological advancement. It's helped us to stabilize the global grids when the grid's operational. It's also exposed the weakness in the power distribution capability when the grid is non-operational and all those DERs just sit in an idle state waiting for the grid to return. This has raised our question of what do we do when the grid drops out? When the grid drops out, the grid following system, by design, senses that the grid's dropped out, is ordered to cease to energize or cease to export power. Said system is required to turn itself off to avoid creating an island, or in other words, provide anti-islanding protection. The issue with all the DERs going offline when the grid goes down is unless they have a battery backup, they're unable to produce energy to their loads and not able to create a grid from scratch, commonly referred to as a black start, by creating their own inertia, which leaves the load they're supporting without any power until the grid is re-energized and the unit can once again sense that the proper phase, voltage, and frequency is there to synchronize to export power. In areas where the power grids are largely grid following, when DERs are looking to find and follow a leader to synchronize to, systems begin to trip offline. Other systems which are following those systems also begin to trip, which triggers a ripple effect and system instability. This is where the grid forming device potentially can offer a solution to bridge the gap between grid following and the real world interactions. Grid forming devices are controlled voltage sources capable of creating the grid from scratch, typically using software-driven synthetic inertia to allow balanced networks that can self-regulate. Grid forming devices do not look to track or sync with the leader. It in fact becomes the leader by generating its own stable internal voltage phasors. How's all this relevant to us with SunSpec Modbus? As interoperability is becoming the key factor in successful integration of DERs onto the grid, we as members of the SunSpec Alliance believe that now is the time to create the new SunSpec grid forming model. Our objective is to integrate the new grid forming model into the current SunSpec 700 series to create a more well-rounded and complete communications protocol package. Our working group has a lot of experience with grid following devices. We're looking for help from people with experience with grid forming devices. We need help from people with basic understanding of the concepts that differentiate following from forming. Concepts like droop control, island mode operation, intentional islanding, microgrid operation versus anti-islanding, virtual synchronous machines, virtual oscillator controls, pull slip, states of grid forming, synchronization, etc. Difficulty we're going to have with this model is going to be to find ways to implement these type of concepts into the SunSpec Modbus model by building upon our existing SunSpec 700 series protocols, not replacing or violating them. If anyone out there is interested in joining our working group, I ask that you please reach out to membership@sunspec.org. Reach out Aaron, the team, or if interested in joining the SunSpec Alliance, please do so you can get in and help us out of there. If you know anyone that might be interested that is not in this call, speaking on behalf of just an industry professional for the last 20 years and not necessarily on SunSpec Alliance, but I will state that please, we're desperately seeking to get some help to get this working group up and running and get additional bodies.
Mm-hmm. Awesome. Thanks, Dave. Much appreciated. Yeah, we can see that this will hopefully be a valuable addition to the SunSpec Modbus environment, and there's a lot of work to go on here. We've already made really strong progress with the initial draft model, but more work to be done. So looking for recruitment and contributions of people's energy and expertise to finalize this new standard model.
Hey, Dylan, looks like we have a question from Paul. Paul, you have your hand up if you want to go ahead and ask your question.
Sure, go ahead, Paul.
Yeah, forgive my ignorance. Could you help explain again when the grid forming model would be used? I assume it's not when the grid is up, correct?
Correct. I think that is the general application.
Okay, so right now, hybrid inverters already switched to a grid forming, and you're basically creating a spec to further refine what hybrid inverters would do in that situation. Is that
right? Exactly. To standardize the way that it's communicated to facilitate interoperability, just like with all these communication interoperability standards. The goal is with interoperability is to enable more choice and options for the different devices within a system, lowering costs of barriers of entry, lowering the cost of integrating systems, etc.
So is it appropriate to think of this as kicking in, basically better defining grid forming on an island system?
David Cole, maybe you'd like to respond.
Repeat the last part. You say better defining a grid forming on an island?
The grid forming on an island system. So the grid is, I'm thinking of it from a hybrid inverter point of view, but the grid has gone down, so you're not grid following anymore, but you still want to produce power. So you're going to produce power and put it into an island.
Mm-hmm.
It's not part of the, and you're better defining and hopefully making it more consistent about how an inverter would do that. Correct?
Correct.
Okay, so, I understand.
So there's two pieces to this one, in that one, if you're only looking to do that when it's in an off-grid, there's plenty of standards there, UL 6200 and multiple others that handle power plant controllers, etc. This model, what we're attempting to look at in this one is for that hybrid product. If the utility grid goes down and you switch modes, what does the transition look like when we say, okay, we're ready to come back? The grid has come back. We're ready to come back into grid support mode. What does the communications look like for that? So if you draw that imaginary line that's coming down, everything right now is defined where the flow comes down from utility, goes across that line into a following mode only. Everything is defined with anti-islanding, anti-everything, right? Just disconnect, run away. Now that we have the hybrid machines, we've got rotating machinery, generators, etc., that can in fact support the utility, but there's no communication protocol on how to communicate that back and forth, how to communicate what state the machine is in, or how any of the controls work. This model is being looked at as is it possible to add it in? That's why I tried to emphasize in there that we need this to support the existing 700 series. Is if we wanted to just blow this out and say we're just looking at a plant controller, right? Those exist across the board. If we say non-utility supporting, it's just going to go offline in an island state, that's easy. We have all of that. To try to get the grid forming model in place to support the grid following model without it taking over, that's the trick.
Okay, so this is more than in grid down. This is now the inverter is not just following the grid. The grid is acting like a primary source on it.
Yes.
On the grid. Okay.
Yeah. So
okay, that's a big leap. Okay. I was trying to, you know, when somebody said it was just, you know, like for when the grid is down, I thought, well, okay, we already do that. But yeah, I see now. So
yeah, so
this is basically saying, how can we use the inverter to emulate a rotating generator?
Correct. So think utilities up, everything's fine. Utility goes down. We wanted a seamless transition at my house, and then the utility comes back, and I want a fairly seamless transition. For the average homeowner, they don't want to know any of the technical details that happen in the background. For us as the engineering team, it's a nightmare.
But we have, you know, for that scenario, we already do that. So I'm still, I guess, a little bit confused.
Well,
we have a working group that would love to have you on board.
Okay, I'll go there and ask my stupid questions.
Oh, they're not stupid. I look forward to engaging with you on the team.
Yeah.
Okay.
No, that was good, and thank you for clarifying on that, David. And yeah, you know, a lot of the functionality that these standards get developed to support, you know, companies or manufacturers are often already doing it, just in a proprietary, non-standard way. And the objective is to standardize it to bring down costs and grow the market. So anyway, moving on so we can stay on time. That was a good interruption, so thank you. But and so next topic I wanted to raise here is the SunSpec Modbus for Poland profile. So a little bit of context around here is that SunSpec Modbus has been mandated in Poland and has also recently, their grid code interconnection requirements have been updated to mandate SunSpec certification as well. And over the past 12 months or so, we've had a number of members come to us to get certified, and they've told us the reason they're getting certified is for doing business in Poland. And so we felt as a group that it was important to find a common profile, just like we have a SunSpec Modbus for 1547 profile, that will streamline manufacturers' ability to comply with the regional national grid code. And so we have, based on some of the input we've gotten from our members, we've developed an initial implementation guide or profile for Poland, including the models you see here. Oops, sorry. 701, 701, 702, 703, 704, 705, and 712. However, we haven't had actual input from people physically in the European market or in Poland. We've emailed it out to a number of our members and contacts that are in Poland, but we're looking for broader input, especially considering we don't speak Polish and we don't currently have access to the full set of requirements there. So What we've done is gone ahead and we voted in the work group to promote this profile to test status for public review and commentary. We have not set an official end date because we're really trying to get more engagement from people in the European market, in the Polish market, so we can have a higher degree of confidence that this is fitting the requirements of the Polish grid code. One thing we know also is that secure SunSpec Modbus is likely to be required. This is not currently in with the Polish profile itself, but it is, secure SunSpec Modbus is its own specification and will need to be implemented. So we know that any Modbus traffic done over TCP over a public network is going to need to be secured, and will need to be secured with SunSpec Modbus, secure SunSpec Modbus. RTU devices will be able to continue to participate, but of course they will also need to be paired with RTU to TCP converters that then are secure SunSpec Modbus compliant as well. And we know Poland isn't the only country doing this, having both the functional requirements that need to be supported with standard communication interfaces, but also mandating encryption for anything over public internet or public networks. Just in the last couple of days, we also got notice that Australia is mandating SunSpec Modbus and mandating secure SunSpec Modbus for all TCP public network requirements as well. So, like I said, this is in public review and comment period right now, accessible on the SunSpec website. We're taking comments right now, and we will be working to finalize this in the coming months. And perhaps this will be an activity to get the final input from the SunSpec Europe working groups, all ultimately still being published under the global SunSpec organization for open royalty-free use and consumption. So those are the items for the SunSpec Modbus work group that are ongoing. Next, we're going to turn to look at what's going on in the 23.5 area. So the SunSpec IEEE 23.5 work group. Like I said, there's two kind of subgroups currently going. First one I'll highlight is the 23.5 test procedures work group. Like I kind of teed up at the beginning of the webinar, SunSpec developed the CSIP test procedures for the California Rule 21 profile and requirements back when CSIP or California Rule 21 was first instituted to mandate 23.5. So we developed the first iteration of the test procedures, have certified more than 100 different devices to CSIP over the years, and during last year, beginning of last year, we were officially appointed by the CPUC to lead the next iteration of the CSIP test procedures, having already been the official entity for certifying CSIP compliance and having a mature network of manufacturers, labs, and tools that support and public key infrastructure that support that profile. So we've been making a ton of progress to updating the CSIP test procedures. And at this point, I'm going to invite Steve King of Quality Logic, who's been the member leader of the test procedures, to offer some comments to let us know about the new tests that have been added to the CSIP test procedures, as well as some of the improvements to the overall testing configuration based on the lessons learned from certifying and testing and certifying more than 100 devices over the last couple of years. So lots of improvements. I'll let Steve take us through this kind of first updated version, still currently in draft status, but I do anticipate we'll be releasing the first test status version for public review and commenting here shortly as well. So with that, Steve, if you would like to come on and say a few words, just let me know when you want me to flip through slides for you.
All right, thank you, Dylan. Thank you for the introduction. As Dylan mentioned, the SunSpec test procedure has been the official certification test cases and certification program that has served the California Rule 21-based CSIP program since 2018. And now 8 years since then, lots of OEMs have been certified through the program and through the test procedure as well. So what we're currently doing is the test procedure working group is continuing to update the current test procedure to improve and add on interoperability and additional conformance test. In addition, the test procedure working group is responsible for updating, developing, other profiles, the test cases for the other profiles, such as metering, as well as SAE J3072, which is a V2G profile that Dylan will talk about later in this presentation. So we have already completed the metering test procedure along with the metering profile itself. So that's available from SunSpec Alliance for those of you interested. So what the current scope of effort of this working group is to update the current CSIP test procedure to add in additional conformance and interoperability. And the ultimate reason for doing that is improve the interoperability and conformance state of OEMs that are being certified and so on. So the greater the conformance, greater the interoperability that will exist in the industry. As what has been the case, the tests are protocol tests only at this point. It does not get into, for example, when inverters are tested through the protocol implementations are what we're looking at for conformance. We do not look at the functional behavior of the inverter. That's in the scope of IEEE 1547/UL1741 SB and so on. So with that, next slide, please, Dylan. So this is a rough timeline for the work that's being done. The top line shows the timeline for various profiles that the test cases are developed against. So that currently there's a CSIP 2.1. That's what all the industry participants and OEMs are implementing currently to be conformant to California Rule 21 requirements. And as Dylan mentioned briefly, there is also additional profile working group, SunSpec J3072, which is a V2G profile. I believe that's going pretty close to test status, but again, Dylan will talk about that later in this webinar. In parallel, there is a CSIP working group called IEEE 23.5.1. Many of you may be part of that working group as well. So that specific work group is updating the baseline CSIP profile, which is a technical specification of the CSIP communication protocol, which is based in IEEE 25. So there's an ongoing work that Gordon Lam also leads for that. So it's rough timelines as far as schedule. This presentation is not trying to present a specific schedule to all of you, but based on my understanding, this is a rough timeline to when profile targets are. And please, if you're interested in either of those profiles, please participate in the respective work group respectively. And then the yellow diagram below it is the timeline that we are working against for the test procedure working group. So the update of the test procedures for the CSIP 2.1 to add in additional conformance and interoperability test. Our goal is to basically get that done later this quarter, as well as when the VDG profile gets completed. We'll follow that completed profile and start developing new test cases against that profile as well. And again, when the IEEE 25.1 completes, as Dylan mentioned, the CPUC has a specific order that governs SunSpec Alliance to develop the test procedure against that. So we'll start working on respective test cases for that as well. So below it, the diagram, I show a brief summary of the various scope of work that we're currently involved in. So I won't go through each of them, but just briefly, additional interoperability and corner case scenarios around 23.5 mandatory rules. What are mandatory rules? In the 23.5 IEEE specification, there are a number of shall, must statements. Those are mandatory rules that are that must be implemented for their respective functions that are covered in CSIP. In addition, error scenarios, and also it's important to cover all the requirements in 1547-2018, as well as additional interoperability tests that are done typically by utilities as well as DNSPs in Australia. So we want to make sure those additional tests are also covered in the baseline certification. So the current list of topics are also, as well as a draft document, can be found on the specific work group teamwork site. So the link is there on the presentation if you're interested. You do have to be a SunSpec member to access it, I believe, and SunSpec team, please correct me if I'm wrong. So with that, next slide, please. So this is we have a comment matrix with all the input from all the participants that have provided feedback for the work items for the work group to work on. This list is a living document, so if any new participants have specific input to what you would like to be added as far as test coverage and so on, this comment matrix is also on the Teamwork website, so you could view it by logging on to the website. And then later on this presentation, I have email addresses for myself as well as Kudra from SunSpec Alliance. So feel free to contact either of us if you're not able to submit comments through the Teamwork website. So with that, next slide, please. So some of the examples that we have already completed that's ready for review is in the 1.4 draft on Teamwork. So for example, one of the popular requests that we've gotten is, what about having test cases modify so that the client doesn't have to restart on every test case? So we've added a recommended approach to handle that, as well as any updates that we need to do for 1547, 2018 and .1 test procedure. Any gaps that we have, those also have been added. And then other test cases that have been added are, what about servers making available these functions on different locations other than default locations that we see in CSIP as well as IEEE 25. The standard allows servers to do that. And this has been one of the interoperability issues observed in the industry. So we wanted to make sure those are tested and certified for any new OEMs, as well as other items that you see on the list. We invite those of you interested in this topic to participate in the working group. So we meet on a bi-weekly basis. So if you're interested, my email contact as with Kuja's on the next slide. So Dylan, next slide, please. Yeah, so this week we're gonna cancel this meeting because July 4th holiday here in the US. So the next meeting will be on July 16th. So I encourage all of you who have an interest in this topic to come and participate in the working group. So now you have 2 email addresses for myself or Kudra to contact. So with that, let me hand it back to Dylan.
Awesome. Thanks, Steve. And yeah, in fact, you mentioned the B2G SAE J3072 profile. In fact, this is the next topic for this webinar, and we are here to announce that it actually has been promoted to test status as well for public review in the comment period. I will mention that at the end of this, I'll highlight how to get involved and join all of these different work groups and their meeting schedule and cadence and all that. You're of course welcome to reach out to the individuals like Steve and Kudra, myself, or Aaron if you want to discuss the details, but there's more information, a straight line to joining the Alliance and joining these work groups here that we'll cover at the end.
Looks like we have this raised, Dylan. We had a quick question if you wanted to take it.
Sure.
Go ahead, Greenie. I see your hands raised. If you want to come off mute and ask your question, go ahead.
Do we get a copy of your presentation after
Yes.
the meeting?
Yes, we'll be emailing out the recording and the deck after the meeting.
Okay, for everybody that signed up for the meeting.
Correct.
Right.
Yeah, and we'll post it on the website as well, so even people who haven't registered will be able to access it.
Okay.
Great.
Yeah, maybe the website you need to point that out better.
Oh yeah, yeah, we'll email it out. No problem at all.
Okay, thank you.
Yeah. So continuing on, so just to talk a little bit about the IEEE 20.5 V2G work group, you can see a little bit of a timeline here. We finalized version 1.0 of the 23.5 V2G AC profile for SAE J3072 in September of last year. We immediately started working on version 2.0 because J3072 had been updated and version 1.0 was based on the previous version. So we marked that one done and immediately started working on version 2.0. And in the last meeting, promoted it to test status. And so this specification will be in public review and comment period until August 15th. So we've got a 45-day review period being announced here today. Like Steve mentioned, the test procedure, the 20.5 test procedures work group will and has been working on updating or providing a test profile to validate compliance to this 23.5 V2G profile as well. What's nice about the program with the 23.5 test procedure is many of the tests that can be used for CSIP certification can also be used for a metering profile or a V2G profile. So what we're kind of looking to do is we're simultaneously developing 23.5 profiles and compiling test procedures so we can, on the fly, based on what's required for a different application, configure compliance criteria and test procedures as well. So please do take a look at the 23.5 V2G AC profile. It's already up on the website for you to download and read and submit comments on. We will be, over the next 45 days, taking the input and resolving any comments that we receive in the workgroup meetings. The next work item that we have on the calendar is another V2G application with ISO 15118. There's an amendment 1 outlining the US specific requirements for under this standard, and I believe there's a European specific amendment as well, or it might be under the same amendment. That will be finalized and published in August or September of this year, so that will be the next work item in this kind of 20.5 V2G subgroup. I don't know if I can't see the attendance list. I don't know if Gordon is here or not. Gordon Lum is our member leader of that work group. Gordon, if you are here and you want to say a word or two, I invite you to do so. If not,
yeah, Dylan, I'm here,
okay.
But you summarized it pretty well, so there's nothing more for me to add.
Okay.
Like you mentioned, the completed draft is now in test status, so please review it. And again, you also mentioned that we're waiting for the publication of the ISO 15118-20 Amendment 1 SAE, such that we can create an equivalent profile for that version of V2G AC as well. Thanks.
Thanks, Gordon. So this is another call to action where people who have been working or familiar with ISO 15118 have been participating in that ISO or SAE work groups. We are requesting experts in the field to come and help us define this profile as well, so we can make this useful and get it deployed and testable as quickly as possible so the market can get to work in using this stuff. All right. So those are the main workgroup items. The next topic we're going to get to is the announcement of SunSpec Europe. I'm going to pass it off to Erin Mahan, who is the VP of Membership and Regulatory Affairs for the SunSpec Alliance. She's actually currently in Germany right now. She was at Intersolar Europe last week. We are in the process of establishing SunSpec Europe, have gotten the bylaws approved by the German regulators there, and we'll be officially signing those and incorporating this nonprofit, European-based nonprofit, here later this summer. And it will be working on adapting these global standards to the local regulations and requirements and grid codes, as well as participating and leading various grants and research initiatives. So this goes back to our same roots that we had in the US, is where we got started, is proving that these protocols and standards worked and could be used in the local environment through collaborative research with our members. And so we're going to be doing under SunSpec Europe, doing the same push to get this global SunSpec standards integrated into the European environment, and all with the purpose of publishing and promoting these global standards, so members can participate in any global market with their existing communication interfaces. So without dwelling on that more, Aaron, why don't you go ahead and take over and let us know more about this.
Thanks, Dylan. Yes, greeting everyone from Germany. We had a very successful Intersolar Mutant conference, and we just today got finished with the cybersecurity conference here in Erlangen. Erlangen is the home of the Friedrich Alexander University, and we are working with them as well as many of our project partners like Grundig Academy. So SunSpec Europe, as you already know, is involved in several European projects. We were involved in a Horizon Europe project called Interstore, and this was a well-funded project to investigate SunSpec IEEE 2030.5 for flexibility use cases. We were also involved in we are currently involved in a Technische Hochschule Ulm project, the Technical University in Ulm project for Flex Solar Baden-Württemberg. So our newest project with Europe is that we are participating with LF Energy. We will release an open source repository with reference implementations for 2030.5 as well as secure SunSpec Modbus. You can find us at the LF Energy Summit in Berlin this September. And also at that summit, we will announce the launch of SunSpec Europe. Things are going well for SunSpec Europe. Two of our members, Bureau Veritas and TÜV Rheinland, have been selected by the German agency, Federal Office for Information Security and Technology, as the two responsible parties to test for the Cyber Resilience Act. So that is big news, and we are proud of our members for leading the way in Germany and across Europe. In Europe, a few other notifications, of course. Dylan mentioned Poland. So at the Intersolar Munich conference, I got confirmation from our partners at Jinlong Solis, who do participate in these Polish work groups, that Poland implemented the SunSpec Modbus certification requirement because of the cyber attack in Poland in December 2025. That's big news. They also told me that it's possible that Hungary will implement the SunSpec Modbus certification next. So SunSpec Modbus in itself is very important for device transparency. And as we continue to work with Poland, we will also get them to implement secure SunSpec Modbus. Also in Europe, the heavy-duty trucking charging standard, SAE J3068, is being used. So that means that we are securing Europe by making sure that those heavy-duty trucks can continue communicating with the grid. We are working on Flex Connect and dynamic pricing programs through the Technische Hochschule Ulm Flex Solar Baden-Württemberg project and others. And we are participating in the European Performance on Buildings Directive, EUPD, with our partners at the KNX Association. We have already mapped SunSpec Modbus with the KNX Association, and that mapping is now taking flight. People are implementing both SunSpec Modbus, secure SunSpec Modbus, as well as the KNX standards in order to give better insight to their energy management systems, as well as the grid operators who want insight into these buildings. Like Dylan mentioned, the bylaws are coming along. We were approved by the financial office, and that is a big deal. We were also supported now by the headquarters of the Fraunhofer Association, and that is Europe's largest research organization. So we are proud of these accomplishments. We are supported by the leading technical universities, not only in Germany, but across Europe. Also, we are prepared to apply for several European-level research projects, and we're doing that alongside our research partners as well as alongside our manufacturing partners in Europe. We will sign the bylaws in summer 2026, and if you would like more information about that, please email me or membership@sunspec.org. So some of the reasons that SunSpec is coming to Europe is because we were requested by our project partners there to come to Europe and support them to create economic value. So that means that we decrease time to market. Open standards mean we don't have vendor lock-in. We're creating partnerships and industry mappings. So for example, I talked about the KNX Association mapping. That's very important for smart building performance. We're also doing mappings with OCPP, and that will help the alternative fuels infrastructure regulation that's upcoming for the EU, as well as an EE-bus mapping, which will help us gain more visibility and more participation with heat pumps and other such household devices, as well as other devices on the grid in Germany under paragraph 14A in the German grid code. So SunSpec in Europe obviously decreases regulatory risk and enhances programs like heavy-duty charging, Flex Connect, and dynamic pricing, and these directives that Europe has. Dylan, will you go to the next slide? So at the moment, Europe's decentralized energy system speaks a lot of languages, and many proprietary communication systems increase integration costs and complexity. That also creates more attack surfaces on the grid. So SunSpec Europe is connecting these established protocols and enabling coordination among our members. That way devices, grid operators, and markets can finally work together as one system. Some of our SunSpec Europe founding members include the members that you see here, among others. We are participating with people around Europe to make sure that Europe's energy grid is resilient and profitable for our current members. I would welcome any questions that you have now or at the end of the session. So I see that, George, you entered the European Union Agency for Cybersecurity, ENISA. Would you like to expand on that, or was that a suggestion for who we should get in touch with?
Yes, you should get in touch with them. They're in charge of the whole thing. They're secure. This process, Poland has only expedited this process. They were ahead of the United States by at least 2 years, and they're moving quickly with haste, as you can guess, and you know why. Same thing's happening here in this country. So we're moving quickly on our side too, in partnership with NERC. Does that help?
Absolutely, yes.
And your standard has been included. It has been included in the draft second edition for 6200, which uses microgrids and grid resilience.
Love to hear it.
Wonderful. Thank you so much. Yes, there are so many organizations in Europe that are talking about SunSpec right now. And those include, for example, the European Union's Data for Energy group. They recently worked together with Fraunhofer as well as Panasonic to publish a threat vector analysis of unsecured Modbus implementations, as well as other groups across Europe are streamlining which standards are being used, and SunSpec is in those conversations. So I'm happy to connect with someone at ENISA, and I think that we already have some contacts in that working group as well.
Which is exactly why it's so important that we have a local presence there in Europe, as there's so much and that fast-paced activity and development, particularly around cybersecurity. We need to provide the industry a place to collaborate and come together and pull all these threads together, and also enable the existing members and products to participate in these markets with their existing communication interfaces.
Yeah. Paul, you have your hand up. Paul, would you like to ask a question?
Well, it helps to turn the mic on. Did I hear you mention that there's an open source implementation of the security, SunSpec Modbus security?
The open source reference implementation will happen in September with LF Energy, so it's not quite there yet. However, yes, we will open source as much as we can for a reference implementation. There's a reason for this, of course. The European Union is very focused on sovereignty, and to fulfill the sovereignty requirements, they're focusing on using open source, not only softwares, but also implementations for standards in the energy sector.
Yeah. I think it'd be useful when we go to implement it, it'd be useful to see a reference.
Absolutely.
So,
yep, we agree. So that's what we're doing with the Linux Foundation there.
Yeah, that's a big deal. The Linux Foundation has asked us for a while to begin a project with them, and we are happy that they trust our implementations and they want to continue working with us in the future.
And ideally, it's our members. So our role here is to be provide the platform for our members and experts to collaborate and define consensus-based approaches. And of course, we're here to support all that by launching these types of open source initiatives, along with things like SunSpec Europe and these work groups.
That's right.
So speaking of, this is where the part where I invite everybody here to share the news that we've shared with you today about these ongoing work groups and the standards development efforts going on within the work groups. The SunSpec Modbus work group meets Wednesdays at 8 a.m. They vary between every week or every other week. The next meeting is next week on Wednesday. The SunSpec 23.5 B2G work group meets Thursdays at 8 a.m. Pacific. They will also be meeting, I believe, next week. And the 23.5 test procedures work group, led by Steve Kang, meets, as he said, every other week. They have a small ad hoc group that also meets as needed to do a lot of the the in-depth sausage making, and then we also have like regular large group monthly meetings. And all SunSpec members are more than welcome and invited to participate in any of these activities and join the small groups, the big groups, be active contributors, writing the actual copy, or passive observers and commenters. We're always on the hunt to get more experts to contribute and lend us their expertise to make these as high quality and useful as they possibly can be to enhance and grow the overall DER industry. So with that, I invite you all, if you're not a member already, please join the Alliance. You can go to the website and fill out the membership application and join. You can contact myself and Aaron if you have questions prior to joining. And if you are already a member, you can go ahead and sign up for the work groups in the member portal. And again, our door is always open to talk to you, answer your questions, and help you get looped in, both in the meetings and the separate collaboration project management platform we have in Teamwork, where the draft specs and comment and asynchronous collaboration happens. And with that, it's right at the top of the hour. Oops, just got to 2:01. So I really appreciate everybody's questions, your attention, your participation. We can hang out for an extra 5 or 10 minutes if people want to ask questions. But thank you all for your time and attention today.
And thank you, Steve and Dave, as well.
Absolutely.
Dylan, a quick question on the
Sure.
Modbus security.
Mhm.
Is the intent that would roll into the Modbus certification, or would those remain separate certifications?
Good question. We haven't gotten to the point of actually offering or selling the service yet because it's still in test status. Initially, I think it'll be a standalone secure SunSpec Modbus certification because it's got its own dedicated test procedures. I do anticipate at some point, that a new product that supports SunSpec Modbus TCP will want to get security certification at the exact same time, and then we'll likely, we can do all that in one go and bundle it up and have it all done under one engagement. Yeah, in the early phase, it'll be separate, I think, because they're separate sets of tests, but then they can easily be combined.
Okay, thanks.
Mm-hmm.
So since nobody else is asking questions, I'll continue.
Sure.
So back to the grid forming.
Mm-hmm.
Who could I talk to understand the fundamentals there? Because clearly I'm not seeing something.
Yeah. Well, the best place is to join the work group itself. The people talking about it.
I'll do that. The problem I found is that the work group, it probably assumes a base understanding that I don't have yet.
Yeah. Well, this is actually one of the purposes of having this webinar is to get more experts in the specific area. I think that the people that are currently meeting on the SunSpec Modbus work group, they're all feeling like Dave said, they're all more experts on the grid following functionality. So there's an expert enough to know the things that they don't know, basically.
Right.
And we need more people who can fill in those gaps. But yeah, I mean, it is a great community. They're expert in their fields, and they have enough information to know the things that they don't know. So it is a good opportunity to talk through.
All right, I'll jump on that.
Great.
I can jump in there, Dylan, real quick and say, Paul, that the group that we've got that's looking at this, like I myself am a double E by experience. I've been doing interoperability. I've been with the SunSpec group here, I think, for about 8 years now. Really focused on 700 series. You know, the last 5-6 years would be an expert in the 700 series for SunSpec Modbus. I understand the protocols. I'm also a power engineer. I understand 1741, 1547. I've sat on those TCs for years. What we're bumping into, and the working group that we're mentioning on here, there's like 6 of us. It's not a big, massive technical committee that's doing this. There's 5, maybe 6 of us that are getting together to sit and look at it. What we're bumping into is looking at things that, when you look at the existing SunSpec Modbus platforms, there are direct conflicts. Like if you look at something that just says enter service, right? There's a set command that just says enter service. And in a grid following mode, that's a very clear, very easy, right? What we want to do to synchronize with it, you just go look out there, you look at the voltage, you look at the phase, right? Those are very easy parameters. You just look at it, you're done. But if I tell you I'm a grid forming, now what's the piece? As Dylan said, what do I don't know that's in the middle? George Blank is on here. He's a good friend of mine. It's also UL 2200 and UL 6200 expert with UL. We look at these as an opportunity, in that we've been on the other side of the equation for so many years of, damn it, why is nobody looking at these items? That now that we have a complete blank sheet in front of us, we're like, wow, we could write these requirements. But we're also have to be very cautious and cognitive that there's an entire set of really well-functioning, well-defined, 701 through 715 that we're going to try to handshake with to do it. So I think just the fact that you're aware of the buzzwords that you said and the functionality of what it does in which modes completely qualifies you, right? With the group.
That doesn't say much, but okay.
Well,
I don't
Paul,
consider myself an expert.
Paul, if that helps any, I used to build advanced bidirectional industrial inverters that were grid formers. So I have to tiptoe because I'm now working for UL, but I used to build them, and they don't work the way people think they do. There's always the traditional belief that you form a power on the bus bar and all will follow. That's not the way it works. Inverters are not inherently magnetic. They don't follow Lenz's law. They are control oriented. This is where, for you guys at SunSpec, it's going to be a critical issue. Controls, communications platforms, and data packets are essential. Okay? Right. When you're doing these systems, are the systems in an array configuration, such as a standard inverter? Don't know. Got to look at that. But what must always be established is prime inverter first. Right. It's the one that sets the profile. And when you're in grid following mode, on the utility mode, it's where people use the term hybrid. That's not really accurate, because a hybrid inverter is an inverter combined with something. It is dual mode. So a single, you literally, a lot of times you have state engines that flip on you. Right. So you're in grid mode, you're in grid following mode, utility recedes. You sever your connection and you switch modes. Right. And you're now in grid forming mode. Right. Is this helping?
It's helping. Where I'm trying to picture, and admittedly, I have a narrow view of residential hybrid, what we call hybrid inverters. You're right, hybrid's probably a bad term. And I'm trying to understand where the communications would be going to and from for this for this.
That's relatively easy. I'll explain that one. I actually give presentations on this stuff all the time. So your prime inverter is in a communications network, period. It has data packets that are transmitted over an example, SunSpec Modbus.
Right.
Or it could be an RS-485 communications daisy chain system, whichever.
Right.
but it's for long distances you really want something else. So that data packet goes out and it announces, I am prime. I am the master inverter. You will all now follow me and be subservient.
Okay.
And then it establishes its footprint.
Okay.
What my profile is.
So this, all right. I think I understand. I'll give an example, a hypothetical, just to test myself here. So I work for EG4 and there's Tesla. Okay. So conceivably what could happen here is you have both of them in a network, and in a power failure, one of those, the handshaking we're talking about here is one of them becomes the master that controls the other one.
Yes.
Correct? Okay.
That's correct.
Yeah. All right. So yeah, I get it now. I mean, like I can speak for the EG4 inverters. There is a handshake between parallel inverters that does that, right? And
yes.
It's very, very proprietary, very
absolutely.
Bespoke.
It is absolutely proprietary.
Yeah.
But it works. But what you're saying is if you have multiple sources that want to participate in this island, this is how they would communicate.
They would, and you would have to establish in the programming who is first online. And usually it could be the first one that identifies the situation would be the first online, closest to the point of common coupling. There's other ways to do it, but these are all micro information. It's important that the data packets go across a secure communications port. That information is transmitted and must be known. You have to establish the profile. On the profile setter will tell them, I am lead inverter, my frequency is this, my voltage is this, my output is this, and my phase angle is this. And then you establish how many units are necessary to be online for that site. And then each one of them comes online and shares proportionally the kilowatt. Okay, because they are not KVAR oriented as a synchronous system is, they have to create their own concept of synchronous. That would be through the kilowatts and the amount of amperage shared proportionally between the systems. This is all reality. This isn't theoretical.
Right.
But we're getting into the weeds. You asked for this.
No, it's exactly what I was trying to understand is what's the problem trying to be solved, and I get it now. It's basically for when you've got multiple possible masters, how do you sort this out?
Well, that's a priority, a scheduling of priorities.
Yeah.
There's also some other things associated with that too.
Right. Yeah. Obviously, there's details that you can get into the weeds real quick. I mean, right now there are systems out there that will work. If they'll work with a traditional string inverter or a micro inverter, and just automatically become grid forming and use frequency shift to control those others. But this is more sophisticated than that.
Yes, in order to do the frequency shift will only go so far. The inverters, and this is something that's already known at the government, oscillation.
Right.
You get into the argument, those systems start to argue, you will get an oscillation across the bus bar. They must be in communications. If you're going to try and push it through brute force of KVAR or whatever you want to try and do, you're going to run into a droop mode configuration. That's where everything has to slow down to be at droop mode speed, which is, I used to do that as a young lad in the 80s, flip my gensets to droop mode on the ship, and it was dumb. It didn't work very fast. If there was a load shift, you were out of luck. That system went down. So it's very delicate. That's where dynamic droop is your first evolutionary step. Then it's dynamic isochronous mode is the next one for inverters, because they're going to work that way. Don't even think about paralleling with generators, because again, communications loop is essential. They will not see each other at all.
Yeah. Generators are going to be grid forming. Damn it. And there's nothing to do about it, right?
Well, it depends. It depends. If everybody's evenly sized, they will get in a tug of war. That's why something has to be established. And that's not even counting synchronizers. Those are synthetic KVARs.
Right.
The synchronizers will ensnare and create that nice little waveform angle, and it'll be nice. Everybody will follow it. Is it 100% reliable? No, but it's a nice idea.
Mm-hmm.
It's an interesting discussion. I appreciate it, guys.
Yeah, thank
So
you.
Sorry for taking your time.
No, it's great.
Yeah.
I
No,
hope
this
you
was a-
guys. I hope you guys come online to the next SunSpec Modbus work group and continue having this discussion, because this is exactly what we need.
I keep forgetting to invite myself to these things. David Cole gets a hold of me and jerks my chain.
Yeah. Dylan, on that note, how do we make sure that we're getting these names onto the meeting request list?
Well, if you enroll through the member portal, we add you. But I've marked down who's speaking, and we'll get you on the calendar invite.
Okay. Did you see Dr. Kim put in the chat that he was interested as well?
I did not. I can't see the chat at all because I'm presenting.
Okay.
But we'll digest all this afterward. Look through the chat and get it.
Perfect. Erin sent me a separate email on the side. We were chit-chatting, so I put it into her as well, so she's aware.
Great.
So if
All right.
anybody needs anything, please let me know.
Will do. Well, I need you at
Okay.
the next work group meeting, but we'll follow up and give you the coordinates.
Awesome.
Very
Thank
good.
you, everybody.
Right.
Enjoy the 4th.
Oh, that's
Yeah.
right. Have a good one.
Yep.
Bye.
Bye all.
Bye-bye.